Hello everyone. Our lesson today is about lenses. As we studied in the previous lessons, we mentioned two types of lenses, the convex lens and the concave lens. We mentioned some differences between these two lenses. Today we will talk about convex lens as a magnifying glass. From the title, we can understand that convex lens, we can use it to make things looks bigger. So if you look at uh, this drawing, okay, here you can see the squares, and here we have the convex lens. And as you can see, what it's happening to the size of this squares, it's looking bigger. Why? Because here we used a convex lens. Now, explanation for it. In lenses, we talked about the principal focus, about the lens, okay, and about the object and the image that will be formed. So, for images, we said we have two types of images, the virtual image and real image. We will see here what kind of image will be produced by convex lens. If an object is closer to the convex lens than a principal focus, the rays never converge. What's that mean? Here we have the lens. Here it's the lens. And here it's the principal focus. Okay, principal focus, we said it's the point at which the rays, it will converge or it will meet. But as you can see here, what do we have? The object, here we have the object, and the rays are passing through the lens and they are refracting or bending. But if you notice here what is happening, these rays are not meeting with each other. So what's that mean? Instead, they appear to come from a position behind the lens. The image that it will be formed, it's upright and magnified. Here you should focus on these two words because we said before, when we talked about lenses, we talked about the images that it will form. Sometimes the image will be it will be upside down. Okay, here the image, it will be upright and also it will be magnified. When we will have a picture, a image that it's upright and magnified, when the object, it's closer to the lens, to the convex lens, than the principal focus. Usually, it's like objects, they are here, they will be here. I mean, here behind the principal focus, we will have object, principal focus, and lens. But here, it's opposite. The object, it's closer to the convex lens than the principal focus. So a kind of image that will be formed in this case, it's a virtual image. What's that mean, or why it's virtual? Because the rays will never meet in a point, okay? Because no rays actually meet to form it, and it cannot be picked up on a screen. Used like this, a convex lens is often called a magnifying glass. Again, we can use convex lens to make things looks bigger. Why this it will happen? Because the object, when the object, it's closer to the convex lens than the principal focus. So the image, it will be upright and magnified. This kind of image, what do we call this kind of image? We call it a virtual image. Drawing accurate ray diagrams. Here what we will have, you will need to draw the ray diagram, and also you need to determine the position of the image and the features of the image, how it will be. Will it be bigger, smaller, upside down, or upright? So here what do we have? We have this example. To solve this kind of questions, you will need to use a graph paper. Okay, if you will focus here, we have this graph paper. Now, the example, it says an object 2 centimeters height stands on a principal axis. So, which one is principal axis? Here, these dots, this it represent the principal axis. We say the principal axis, it's the straight line that it pass through the center of the lens. Principal axis at a distance of 9 centimeter from a convex lens. Now we have the object. This object, the features of this object are what? It is 2 centimeter high and 9 centimeter from a convex lens. So what's that mean? It means this is the lens. Okay, if we will measure 9 centimeters from here, from this point, from the center of the lens and to this direction, until it will be 9 centimeter. So in 9 centimeters, that's mean here it's the object, and the length, so, or the height of it, it's what? It's 2 centimeter. Now it says if the focal length of the lens is 6 centimeters. Focal length, what do you mean by focal length? We say it's the distance from the center of the lens to the principal focus. So if we will measure from here to here, okay, 6 centimeters, that means here is the focal length, and also from focal length we can determine where is the principal focus, because principal focus, it's important point. We will depend it we will depend on it when we will start drawing. Now the question is what is the image's position, height, and type? We will see the image. Is it virtual or real? Is it bigger or smaller, or is it upside or up down? Is it upside down or upright? Sorry. Now we will start drawing. Firstly, we will draw a lens. The steps are: firstly, draw a lens. Then draw the principal axis, these dots, a straight line. Okay. Then after that, you need what? You need they gave us the features of the object. The object is 2 centimeter high and it's 9 centimeter from convex lens. Here in this diagram, what they did, they say 1 centimeter represents 2 centimeter. What's that mean? So just like to make your drawing fit in one page. Okay, so instead of 2 centimeters, the height of it, we will say it's 1 centimeter. Instead of 9 centimeter, we will make it 4.5 centimeter. It's like just we will minimize the drawing. Okay. Now steps again: lens, principal axis. Then after that, we determine the points or the principal focus. Now you have the position of the object and the height of object. As we say, to start drawing, firstly, you will draw a straight line which is parallel to the principal axis. A parallel line until the lens, and this light or this ray, it will bend. But to where it will bend, when it will bend, it should pass through the principal focus, and we'll continue drawing it. Then another line from the top of the object pass a straight line passing through the center point of the lens, okay, until they will meet in a point. So here now the two rays met here. Now let's give the features of the image, how it will be. Firstly, image, it's what? It's real. Why it's real? Because it formed behind the lens, and also it meets in a point. So it means we can show them on a screen. Then how it is? It will be inverted. Why inverted? Because it's a real, so it will be inverted. Now, the distance of it, the position of it, okay, if we will count how many squares here, we will see here we will have 18 centimeter, okay, and the height of it, here it was 2 centimeter. Now here it will be 4 centimeter if you will count the squares, okay. You said each one square, it represents 2 centimeters. Here it's 1 square, and here it's what? 1 and 2 squares. So it means 4 centimeter high. Estimating the focal length of a convex lens. Again, here we are talking about what kind of lens? We are talking about convex lens. Then, focal length. What do you mean by focal length? Focal length, it means the distance from the principal focus to the center of the lens. But in another point, in another meaning, we can say a distance from an image on a screen to the center of the lens. Okay, so how we can do it? We can do it in this way. Okay, let's watch this video.
This is a very quick way to find the focal length of a convex lens. A convex lens forms an image on a piece of paper, and all you need to do is simply to hold a piece of paper and a circular lens and to literally move the two together. It will work with the light that's coming in through the windows. It will also work with the artificial light in the classroom. If you notice, you will find a point, in this case about here, where you can see a very clear image, in this case of the buildings outside Sheffield Hallam University. You might also notice, and the students seem to like this, that that image is inverted. Now if I can hold that steady, what we need to do is to take an estimate of the distance between the lens and the piece of paper. And using that ruler, I can estimate the focal length of this lens to be about 8 centimeters.
So as you saw, this was the easiest way to estimate the focal length. What she did, she just measured the distance between the image on a screen, or here the screen, it was a paper, okay, the distance between paper and the lens. So this is what do you mean by a focal length. Now, convex lenses in a telescope. As you know, telescope is used to make things, the distant things, bigger. But what is the principle of the telescope, or how it works? Firstly, this diagram, it shows a telescope. Here it's the telescope. Okay, this lens and this lens. So these two lenses, they form or they make a telescope. Okay, these two lenses, each one it has a name. This one, the first one, we call it objective lens, because here we will see the object, which it's, for example, it could be the moon. Okay, and the another lens, we call it eyepiece lens. Okay, why we call it eyepiece? Because it's closer to the eyes. Now, two lenses, how it works. When the light from a distant object passes through the first lens, which is the objective lens, what will happen? It will make an image of distant object, where it's what? Behind the principal focus of the eyepiece. Okay? Ray or rays pass through objective lens. When it will pass through the objective lens, it will make a real image. Here it's the image that it's formed by objective. Okay, but where is the position of it? It's what? It's inside the principal focus of the eyepiece. Okay, this F, it's what? It's the principal focus of eyepiece. Where the image it formed where? Inside. Now, what will happen to the image that it formed inside the principal focus? Or in another meaning, we will say, what will happen to the image that it is closer to the convex lens? Let's go back to the first at the beginning of lesson. Here we said, when you have a convex lens and the object is closer to the lens, what will happen? It will form an image, and this image will be magnified. So here, what is happening? Object lens makes an image. Now this image is closer to the eyepiece or to this lens. Now what will happen? This eye lens, it will make this image bigger. Okay, this is the principle of the telescope. Images formed by a concave lenses. So if you look at this drawing, here what do we have? Also the same as the first drawing, squares, and here we have a lens. But here, what kind of lens we have? We have the concave lens. Now the concave lens, what will happen, or what will happen when you will use concave lens? Here, see how what happened to the squares? The squares are showing now how they are showing smaller in size. So here this diagram, it shows a concave lens and an object. Okay, how is the image that it formed by a concave lens? Here it's the image that it forms. Okay, after drawing the two standard rays, okay, the first one parallel to the principal axis, it diverge, it goes away. Okay, and here that second one, the straight line that it passed through the center of the lens. Okay, if we will determine the position of image, we will see here it will be the image. So if we will change if we will change the position of the object, wherever we will change it, we will see always the image that we will get, it's smaller than object. Always the image will be smaller than object, and the direction of it, it's what? It is upright. It's upright, and where it formed sorry, in front of the lens. Okay, it's we cannot get this image on a screen, so what kind of image it will be? So it will be virtual. So the image that we will get it by using concave lens, it's always small, upright, virtual image. These are the features of the image that we will get it when we will use a concave lens. Questions. Question number 1A. An object is 2 centimeters high is placed 12 centimeters away from a convex lens of focal length 6 centimeters. By doing an accurate drawing on graph paper, find the position, height, and the type of image. To solve this question, we will start with the basic steps. The basic steps are what? Firstly, we will draw the lens. What kind of lens do we have? It's convex lens. Then, second one, we will draw the blue line, which represents the principal axis. Then, we will start representing the details that we have on the principal axis. The details that we have, or the information that we have, it says, firstly, an object 2 centimeter high. So the height of the object is how much? It's 2 centimeters. Where is it? It's placed 12 centimeters away from the convex lens. Now, this is the lens. Then we will start from here, this point, the center of it, and we will measure 12 centimeters. Okay. Now, these are 12 centimeters. Each one square, it represents 1 centimeter here. So, here will be the position of the object, and the height of it, it's what? As it's mentioned here, it's 2 centimeters. Then, the dot, the red dot represents what? It represents the focal length. Focal length, we said, is the distance from the principal focus to the center of the lens. So it's 6 centimeters. Now we have all the main points for solving the questions. Now what we will do, find the position, height, and type of image. So the image, it will be formed on this side behind the lens. So now we need to find what? We need to find the position firstly. The first step to draw a rays, or the main rays, or the standard rays, it's what? Firstly, the first step, we will draw a parallel ray from the object. It passes through the center of the lens, okay, and then what will happen? It will bend. When it will bend, it should bend in this, by this direction. The line, it should pass through the principal focus. The second line, we will draw it from the top of the object, passing through the center of the lens, okay, and now as you can see, these two lines, or these two rays, met here at this point. Now how the image it will be, the position, height, and type of image. Let's draw the image. Now as you can see, what happened here, okay, the position, if we will count the distance here, it's 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so the position also, it's 12 centimeters away from the center of the lens, and the height of it, it's how many squares? Here it's 2, so it's the same as this one, also will be 2 centimeters. And what type of image it is? The type of image here, it will be real one. Why? Because we can collect these rays on a screen. Question number 1b. The object is moved so that it is only 10 centimeters away from the lens. Use another drawing to find the new position, height, and type of image. This will be your task. What you will do, you will uh, follow the steps again. Firstly, you will draw a lens, then principal axis, then you have the focal length, which is 6 centimeters. The only thing that it will change here, it's what? It's the position of the object. Here it was 12 centimeters from the lens, but here in question B, it will be 10 centimeters away from the lens. Draw it again and follow the steps that I mentioned by drawing this line, okay, or this ray, and then the second ray. See where it will meet these two rays, and then you will measure the distance from object to the length. Here you can find the position of it, and the height. You will count how many squares, okay, and the type of image. The type of image, also you will say, is it real, virtual, is it inverted, or it's upright? Question number 2. Where should the object be placed if the image formed by a convex lens is to be A. Virtual and longer than the object? Again, to answer this question, you need to draw the lens and the principal axis, then the principal focus, okay, and you will try, okay, to get a virtual and larger the image it should be virtual and larger than object. Here the answer is at principal focus, and if you will try to draw more or to change the position again, so if you will change position wherever the position of the object will be, here from the principal focus to the lens, toward the lens, okay, in any position here in this area, okay, so you will get the image, it will be virtual and it will be larger than the object, okay. So getting virtual and larger image, larger than object, so where it should be, you will say at principal focus, okay. Or maybe you'll have a question, it says if the object is between principal focus and the lens in any position here, how the image will be. Also you will say the image will be virtual and it will be larger than object. B. Real and the same size as the object. The answer for B, it will be in this way. So where the position of the object it should be, in your book the answer in your book they said it should be farther than or farther from principal focus. So to make it easier for you, for the drawing, always make these points f1, f2. What's that mean? Principal focus number 1, principal focus number 2. How to make or where to draw the principal focus number 2, you will measure the distance. For example, if the distance from f1 to the center it's, let's say, 5 centimeters, again here from f1 count 5 centimeters, then you will have f2, okay. So at this point at f2 or principal focus 2, the size of the image will be the same. And also at the same time it will be real. So to remind you, an image from principal focus and any position here in this area, it will be virtual and it will be larger. Okay, once the object it's beyond the principal focus, directly the image it will be real, and the size of it also it will change. Here, for example, this is the one. Now if we will move here, the size of image will be bigger. Here it will be a little bit smaller until it will reach this point. The size it will be equal. Now see, try it by yourself. The image it should be real and larger than the object. So you need to focus on the words. Okay, real. What does that mean? Where it will be? It should be beyond the principal focus. So it will not be here or here in any one of these positions. No, it will be at these positions. Okay. Now it should be larger than the object. Okay. If you will focus on the answer for B, okay, I explained a point about it. So focus on the answer of B, focus on what I said when I was explaining on B, then you can find the answer. Question number 3, show how you could quickly find an approximate value for the focal length of a convex lens. The answer for this question, it's we mentioned it when we mentioned it in the video. Okay, we said you will have a lens and you will put in front of it a paper, for example, or a screen. Okay, you will move the lens until you will get a clear image. When you will get a clear image, then you will measure the distance from the screen or paper to the lens by using a ruler or any instrument. Then you can determine the the focal length. That was everything for this lesson. Again, when you will finish watching this video, please write a comment. Many students, they are not writing their names. So for those they are not writing their names, please write your name so I can make sure you receive the video and everything it's clear in the video. Your task for this lesson, it will be solving the questions in the workbook. Thank you and have a good day.